Tutorial 2, question 10. Are you ready? If you're already ready, then you type 1. Yeah, so I plan to change it to week 6 and week 7. That's why I asked you all whether week 7 Wednesday morning you all free or not. So if okay, then when you okay, then the lab should be 6 and 7. Ziyuan, okay, ready? Okay, let's look at this tutorial 2 question 10. You wait for me to confirm. Confirm no lab in week 5 already because I need to attend a 1 week training. So whether change to 6, 7 or not, I need to confirm. I'll wait for the lab technician to arrange the menu. I will inform you all later, okay? And tomorrow no class, so we stick back to today and Wednesday 5 to 4, 3 to 5:30, right? Okay. Any question? Then let's go to this tutorial 2, question 10. This is the only question we haven't discussed, right? So two balanced three-phase loads are connected fed by the three-phase line having series impedance. Okay, this is a line impedance. One of the load is this one, and the other one is at 132 kilowatt, at unity power factor. The line-to-line voltage at the load end of the line is 2200/3. Compute the line-to-line voltages at the source of the end, then the real and reactive power, then the total real and reactive power at the sending end of the line. Then, this is okay. Okay, can you understand the question? So basically, you need to. Yeah, I forgot to. Okay. Yeah, because since I talk about the what is it? So I'm so sorry. Talk about the class replacement. Then I spoke already. Yeah. You have to start to watch the. Hey, what is my last one? Yeah, you have to start to watch the lecture 4 video already. Get ready, lecture 4 video. And later I will brief you all the main point in lecture 4 as well. Okay, so far so good. Okay, so how are you going to draw this out? You have to draw this out in order for you to imagine it. You can see, right? Bigger. So two balanced three-phase load, so means they are connected in parallel. Okay, so you have a three-phase line. That means you have two loads here. Load 1 and load 2. Can see, right? Then these two loads are in parallel. Okay. Then there is a line impedance. So there is a line impedance. The line impedance actually is this one. 0.4 plus J 2.7. So 0.4 plus J 2.7 here. Okay, something like this. So then what they say? Okay, this one done already until here. Okay, then one of the load. So this one, this is a load properties. So nothing first. The line-to-line voltages at the load end. Okay, so load end, where is the load end of the line? So load end of the line. This is line. So this side is source end. This side will be load end. Understand? So the 2200 will be here. 2200 3 will be here. Can you get it? 2200 cert 3. Okay, will be here. Okay, then now they ask for the line to line voltages at the source end of the line. That means now they want to know what is the V here, VS. Question A, part A asks for VS here. So how to find VS here? So basically, basically, if you want to know they say they want to find the phase voltage. Okay, at this one we call V2 at V2, so V equals to 2200 sub 3 divided by sub 3. So it is 2200 watt, and then in zero angle again this one zero angle as reference. So they want to make the VAN. Still remember the story VAN equals to zero angle. Then the total complex power at the load end or the load end here. So what is the load value? The S for the load okay is equal to load one is, so you need to change the load one info the properties here. 560k 0.0 560 load one 560 so VA. What is VA? VA stands for S, right? So this is S. Then can you get the angle? So you need to change this one, power factor. So shift cos 0.707. So which is, I think it's 45 degree, right? So which is 560k angle 45 degree. Are you okay? Then the other load 2 will be equal to 132 kW. This is P. Okay, so basically when you change the total load means both of them plus together, load 1 plus load 2, which is just now the 560 angle 45 degree plus with 132 K. Okay, can you get what I mean? Because this load 1 is actually in S complex power. So means when you change it to rectangular formats it will be 395.91, I think so, plus 396.05 J. So the real part will be P, the imaginary part will be Q. Okay, but then for load 2, straight away is P. Okay, straight away is P because of unit kilowatt. So you look at W, then you know this is P. You look at this VA, you know that 560 is S. Can you understand what I mean? Hui-san, can you understand what I mean? Yeah, that's good. Then here, you use your calculator, change it to complex number, automatically you can plus together. They will help you to change your form. You don't need to change to rectangular formats. Straight away, press like this, then plus 132K. So they will give you, supposedly you will get 528 plus J 396. So which is equals to, if you change it to polar form, it will be 660 angle 36.87 degrees. Any problem so far? So this is how you get the load n. So you combine both the load together. Then if you want to get the voltage here, basically you need to know the current. I. Okay, so once you know the current, then current multiply with the V equals to IR. V equals to IR, okay, or IZ impedance. So current times with here, you get the voltage here, right? Current times with this one impedance, so you get the voltage here, right? So basically voltage here plus with voltage here, then you will get the voltage here, Vs. Okay, So what they did is, you already got the load, so you can get the current. I will be equals to S over, you have the formula, right? S equals to 3VI conjugate, right? So if you want to get I, then it will be S over 3V. Conjugate if you put here first. Then S will be this 660 angle 36.87 divided by 3V. I write down this is a K. So 660 K angle 36.87 degree divided by 3 times of 2200 watt. This one, 2200 watt. So basically you get 100 angle 36.87 degrees. So if you want to remove the conjugate, then you get 100 angle negative 36.87 degree. Why? Why is divided by sub 3? It is because they change the this is line to line, right? They told you that this is line to line voltages. So that they want to change the line to line voltages 220 sub 3 into phase voltage. So they divided by sub 3. Okay. Okay, that's right. Then you get current. So once you get current, then it's actually okay already. Yeah. So if you want to get Vs sending end voltage, it will be 2200 angle 0 degree plus with current 100 angle negative 36.87 degree multiply with the just now the the impedance of the line 0.4 plus J 2.7. 0.4 plus J 2.7. Okay, then here you are going to get 2401.7 angle 4.58 degree. So from this, if you change it to Vs line to line, then times multiply with sub 3. So we get 4160. Any problem? No problem. Okay, right. Then we continue to part B, the total real and reactive power losses in the three-phase line. So you know that line will be here, right? So it means the impedance is 0.4 plus J 2.7. So you can use the formula B. So it will be three line losses. So it'll be actually is I squared R. Okay, three phase, so 3I squared R. So will be 3I is 100. Okay, the magnitude of I is 100. So power 2. R is basically not R, actually Z. So it's actually 0.4 plus 2.7 J. So you settle this, you basically get 12 kilowatt plus J81 kVAR. Does this anything to do with the per phase and three phase? Yeah, three phase. Is related to three phase. Eh? Balance three phase load this thing is related to three phase. Consider per phase analysis because it only consider per phase, it only consider one phase only. So instead of considering three phase, phase A, B, and C, then they only calculate for one phase. So this is what we call per phase analysis. Means instead of A, B, C phase, we only consider normally phase A, one phase. Nicholas, am I answering your question? Yeah, this is three phase questions, and yeah, it's a little bit tricky lah. I mean, complicated because it add in the real and reactive power losses. Okay, so power losses through the line, that means that you don't need to consider the load side. You just need to look at the line side, then use the I squared R Z lah actually. I squared Z here. Okay. Then part C. Part C will be, what's the question? The total three-phase real and reactive power supply at the sending end of the line. Okay, real and reactive power sending end. Also, sending end of the line is here. Just now you find V only, right? Then now they want P power. So how to find P? Normally we not say P lah. We now upgrade already, so you introduce S. S three phase at the sending end be equals to 3 VI conjugate. So will be so VS. Just now we use just now here we use a V2, right? V2, which is the load side. So now you need to use a sending side. Sending side, because you already get the sending side voltage, right? So means that basically is this two, sending side voltage times multiply with the current. Okay, then you get 540 K plus J 477K. Okay, so basically what they want to ask you to check is your sending end power actually equals to your receiving end power plus the line losses. So means this one sending end should be equals to just now this one 560K, receiving end, sorry, this one 660, 528, sorry, 528 plus J 396. I think it look at P only. I think so. So means this one plus with line power should be equals to the sending end power. So this is what they say. They ask you to check that the total three-phase complex power delivered by the source equals to the total three-phase complex power absorbed by the line and the loads. Okay. Any question? Oh, basically, actually, angle in you want to put in also can. It doesn't really have any problem. Just that basically when we consider some power losses or I mean, and a lot of way actually they just want to have magnitude. But of course, you may feel confused in the exam whether you want to put in the what you call the angle or not. Definitely, it's okay to put in angle, no problem. Okay. sorry, won't the answer is different since the resistance is complex. No, resistance is not. I can't understand. The resistance is complex. No, 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 no. Then we will look at the magnitude only. Where is it? This one. Oh, won't. Supposedly isn't not really have big problem. Yeah, I got what you mean. But don't worry about this. Okay, in your exam, you just put in the angle. Okay, to do all the calculation. Okay. I get what I mean. I get what I mean. But then I don't think you have any problem here. Okay, so basically yeah, this is actually something a lot of students may ask also. Okay, like why we don't want to use the angle, but actually okay to put in the angle. Ah, actually okay to put in the angle, but then yeah, what they want to know is actually the magnitude of the line losses only. So that's why they don't care about the angle. Okay. Any other question? RE students, any questions? If no questions, then means tutorial 2 already done, right? All the questions. Is it? Hello. No questions. Then RE students, today you are very quiet. Okay. Then no questions, yeah. Then we go to the extra three-phase questions. So have you all done this? Try. So I already give you the answer, right? Can you get it? Oh, question 4 you can't. Okay, let's look at this. Others RE students? Are all RE students go for tea break already? Is it? Okay. Okay. Let's look at this. Question 1. In the Y delta systems in figure 1, I plan not to discuss all if you are okay. If you are okay, then no questions. Then means I straight jump to maybe question 4. Is it okay? Or you want me to go through all? Okay, maybe quick one. So in the Y delta systems, the source is positive sequence with VAN. So this VAN, actually this is actually not a good drawing here. This drawing from another book. So this N actually is not A, B. Supposedly, this is AB. I mean, this VAN is not linked with A and B. It's linked with another line called N line. Okay, so VAN is 240, and then the phase is ZP. So calculate the line voltage and the line current. So means You need to check off. So whether this VAN is definitely not the same as VAB, right? So means you have to use a formula. So to change it, the AN to AB, so you need to use a formula. VAB equals to sub 3 VAN angle 30 degree. So just apply this formula, then you will get the answer. 415.69 angle 30 degree. Okay. Then the line current, then means yeah, then you get your AB already. You want to get I line, so you need to get IAB, means this one IAB here across the load here. Current across the load will be equals to VAB divided by ZP. So you get the IAB value 115.29 angle 86.31 degree. Are you okay? So once you get your line, load current, then only you need to change it to line current IA. So are they the same? Of course they are not the same, because you go in here, they separate into two, right? So they are not the same. Big students? No, you are not weak, right? Yeah, as long as you put in effort and then do your exercise and work, should be fine. Yeah, any question, please ask. Yeah. So IA, that means IA, you need to use a formula. Still remember, right? I told you we only had two formula, right? Do you need me to show you the formula? Did they show you, right? The summary list, yeah. One of the summary notes. I actually posted in the classroom as well. This one, you only have two formula. If they are not the same for voltage, then you use this formula. If they are not the same for current, then you use this formula. So basically, IA and IAB, very obvious, right? Okay, you know which formula already. I only have two formula, one for voltage, another one for current. Current equals to IAB and sub 3 angle negative 30 degrees. Okay, so substitute IAB in sub 3 angle negative 30 degree, then you get IA equals to a 199.69 angle 56.31 degree. Okay, so this is why we need to use the formula. AN and AB definitely not the same, right? So you use formula. Then you want to calculate here, we use Ohm's law, because VAB, you can get the voltage across ZP, right? Then you can get the voltage across ZP, voltage divided by the impedance ZP. Then you get the current IAB across the load. So once you get the current across the load, is it same as the IA? Not the same. Your IA come in, you turn into two paths, right? Go in, turn into two paths. That's why you need to use formula. Exam, I'm so sorry that no formula list in your exam. Last time is online exam, then student can refer to the notes. But then if you back to physical exam, that means no formula list. Okay, yeah, power system only a few formula that you need to remember. Then you pray hard for online exam. Who knows? Will they change it back to online? I'm not sure. Yeah, it depends on the COVID cases. For few months later. Okay, obtain it's okay. Don't worry. We only have few formula only. Yeah, if you are lucky, I jaga your exam venue, then perhaps you can ask me formula. Okay, obtain the line currents in the three-phase circuit. Are you okay? So this is basically very obvious. This is Y, right? And this is Y. So it's YY circuit. Obtain the line current. Yeah, you want to get the line current. How are you going to get it? So VAN here. So basically, you know that this AN, right? This one also AN ma. That means do you still need to use formula? Can you drag like that? Drag like that. So that means basically voltage across here also 440 angle 0 degree, right? Agree? So IA, this question easy lah. IA equals to 440 angle 0 degree divided by 6 minus J8 lah. Then you get 44 angle 53.13 degree. Okay. Then minus 120 and plus 120 lah to get IB and IC. Okay. Question 3. Okay, any question? So question 3 is a very obvious delta connection. So 230 volt here, and then forms a delta. So you can see right, this one A here, AB here, this one AB here So it means what? This 230 volt can be across here, right? Across the load. So that's why do you need to apply formula? No need, no? Understand? This is what I say, need or no need to use formula. It's actually very easy to see. You just parallel, drag it over all. Oh, they are the same, then no need to use formula. Like just now, AN and AB, of course not the same then you need to use formula. IA and this IAB, definitely not the same. You have to use formula. Like that only for 3 phase. Okay. Yeah. Then connected to the balanced delta load, determine the value of IAC here and IPPB here. So they want here, IAC here and IPP here. Okay. So basically IPP will be the line current and IAC will be the phase current. Okay. So basic IAC is easy. IAC is basically AC here. So IAC, right, equals to a negative 230 angle 120 degree. Why negative? Because negative here. Your current flow here. Okay. So means your negative here, positive here. Understand? 230 is here. So you need to put negative, then divided by ZL. This one, ZL. 10 plus J8. So you have 17.96 angle negative 98.66 degree. Okay. This is how you get IAC, easy, right? Then IPP, there are a few ways to do. IPP, there are a few ways to do, but then up to you which one you want to use. Let me see. So it's basically, it's basically you use this 1 minute. I'm finding the best way to tell you how to do. Okay, you can actually get, because you already have ICAC So if you want to get IAC, right? How you going to get IC, yes. It's basically here. IC here. Okay. So IC is basically equal to what? Since this is a line current, you go in, they separate into two, so they are not the same. So you need to use formula. So IC is basically to ICA, then angle 3 angle negative 30 degree formula. Not the same, then apply formula. So it will be 16.96. Hey, 1 minute. This is answer correct. Negative 98.66. Anyone? So formula, this one answer correct. Calculation answer. Why I do it 81.34? Yeah, that means this one wrong, right? I think this one wrong. Is it? Supposedly the answer should be 81.34, is it? Oh, okay. It depends on this negative sign. So because I put the negative sign. Oh, okay. So that's why I get 98.66. Okay, betul juga. Okay lah, okay lah. Then no need to change. Sorry, I thought answer wrong. Oh, okay. I get what I do. Yeah. I made a silly mistake. This is negative, wow. But then if I use 360, it's because this is ICA. Then now I'm talking about this is IAC. Now I'm talking about ICA. Okay, so it's basically okay. Then it's basically negative of this value, negative of this value, sub 3 angle negative 30 degree off. Then that's right. So supposing here you will get 31.11 angle 51.34 degree. Then once you get IC already, then actually IA here, IB here, IC here, their relationship is 120 degrees apart from each other. So we can get IB. IB will be 31.11 angle 51.34 plus with 120 degree. So you get 31.11 angle 171.34 degree. Okay. Yeah, thanks, Nicholas. Okay, that's right. Then actually there is another way to do it. The other way will be if you want to find IBB so it is actually equals to IBC plus IBA. So IBB here is actually IBA plus IBC. So you can use back the same thing like this. Okay, then you can get the answer for IBB. So which is equals to 230 angle negative 120 degree divided by the impedance 10 plus 8J and minus 230 angle 0 degree over 10 plus J8. Okay, then you get the same answer. Okay, now why need to minus? Because of BA and BA. Okay, so since you BA, supposing it's AB, the positive sign is A here, so you need to put the minus sign. Any other question? Are you okay? Give me 1 minute. Meanwhile, you digest about this and try to do question 4. Okay, then any question? If you are okay, then type 1. Nobody here already. The afternoon class is, evening class is a bit hard to get your attention. Hello, you okay? All of you. Oh, okay. That's good. Only 3 of you. 4 of you. Okay, then we go to question 4. The line-to-line voltages in the Y load have a magnitude of 440 volt and is in a positive sequence at 60 Hz. So if the load are balanced, and then find all the currents and phase voltage. Eh. Oh, okay. This one is without diagram. So that means line-to-line voltages at Y load. So means VAB will be equals to 440 volt. So if you want to get the phase voltage at the load, then it must be, yeah, because it's this one will be VAB, then phase will be VAN because it is a Y load. So means you are going to have an VAN, right? So that means that definitely they are not the same. So you need to use the formula to change it to the formula. The formula B, you want to get VAN, so you need to divide it by sub3 and angle 30 degree. Divided by sub3. So it's basically equals to 254. I believe, yes, 4. I can let you I can show you the answer. See? It's not what I say, it's the answer from for reference. Let VAN equals to 2540 degrees. So that's why they fix AN as 0 degree. This is what I told you last time. Sometimes yeah, this one if you use formula, supposedly you need to divide it by 30 degree, right? Okay, but then they sometimes they may say reference, then they fix AN as 0 degree. So if you have AN, then you can have BN and CN. Then the line currents. So once you have AN, you want to find line current is very easy already. Voltage divided by the impedance, so you get the answer. Okay, still right? Yes. Of course, you can choose to, yeah, negative 30 degree. So I think you can't get answer because of that. Okay, and as I said in your exam, you follow the questions. Question say if question says so, that means that it will be 0 degree here, then negative 30 here. Okay, so you follow question. If I want you to have 0 degree here, then here I will give you 30 degree. Okay, so in the exam or test, you follow question. So I want to make it standardized. So officially we end the chapter 2 tutorial and extra question. Then now here we go in chapter 1, 2, 3. Chapter 3 is about what? Oh, power transformer. Then chapter 4 is about symmetrical component. Okay. Okay, I done. Then I close this one first. If not, then my laptop may hang. Okay. And chapter 3, A and 3B. Can you see the screen? Okay, so 3A is about power transformer. I think you already watch the recorded video, right? Any problem? So the main thing will be yeah, the power transformer can be very big, yeah. Yeah, step up, step down transformer. So the definition for ideal transformer. Then there is a few things that you need to take note, right? Voltage V2 over V1 equals to N2 over N1, I2 over I1 equals to N1 N2. Okay, then there is a one thing called transformation ratio or turns ratio, this N. Okay, so some book will write N, some book will write 1 over N. So that's why don't care about this transformation ratio. You better remember N2, N1, N1 over N2, okay? So then step up, step down transformer. Then there's one thing called impedance matching. So it's basically if you want to remove your transformer, then you can measure the impedance to the primary side, measure voltage to the primary side, then you can remove the transformer. So it becomes series circuits. Okay. So for example here, so you something like this. Then you secondary to primary, then divided by N for voltage, divided by N squared for impedance. But as I say, this N, don't remember N. N here in this book is actually, N here is actually V2 over V1 or N2 over N1. Okay? But the other book is actually 1 over 2. Okay? So you better remember secondary over primary. Okay? Then if you want to measure the primary to secondary side, then this one impedance, input impedance will be multiplied N squared. This one will be multiplied with N for voltage. Okay. So this is another book. So if you look at this book, actually their N turns ratio is 1 over 2. Understand? So that's why you no need to remember the turns ratio. Okay, you just need to know that E2 over E1, B2 over E1 actually, so it's equals to what 2 over 1 as well. Okay, are you okay? So all this I think I already go through with you in the recorded video. I won't really go in detail unless you have questions. Then I will stop and discuss. Any question? How many of you already? How many of you not yet watch the video? I think maybe you are in holiday mode. Let me check there's 5 students only. Okay. 5 students answer for the 2 from RTE. That means I only have 3 students from RTE answer the questions. That means I assume that the rest of you haven't watched the recorded video. Bye. Enjoy your holiday. Is it? Or you watch but didn't answer? Okay, lor. No, that one is a guide for me whether you watch or not. Are you sure? Okay. Yeah, that's good. Something like this. Then you have any question or not? Okay, I think this one just calculation should be fine. Then equivalent circuit or practical transformer. So this is practical transformer, means a non-ideal transformer. Then you have other thing magnetic flux losses those things. Sometimes in the final exam may ask something like this, theoretical calculation. Then you have this open circuit test and short circuit test. This open circuit test and short circuit test is a video I think in the extra reading material, right? So it's actually to know when you want to know something like whether this transformer after manufacture is the best or moderate quality or very low quality. That means they go through this kind of test so that they will know whether the quality of the transformer. So if you're good quality of transformer, then what will they do? Of course, they will sell higher. Okay, distribution transformer. Then load tap transformer is basically you can change the tap, okay, the ratio lah. Then phase shift transformer. Then there's one thing called auto. This is theory lah. Sometimes may ask you what is auto transformer. Then you explain a bit. Okay. Then then 3B is something important. 3B is something very important per unit calculation that you need to know this and use it in your a lot of chapter the other chapter unsymmetrical fault chapter 7 I think. And of course I say important means it is in the Schneider, of course good quality. Yeah, it's in the final exam 20 marks. Yeah, 20 marks. Okay, last time 40. Last time during COVID time, but actually not lah. 40 actually I have other chapter as well. So 20 marks but now because need to back to 5 questions, so I separate into, actually it's good thing for you, good news for you. So the other question I separate out and not the continuous questions. Easy? Yes, very easy. This is very easy, but then a bit troublesome. But it may be confused for you if you first time get to know about it. So it actually what they want to mean is, you have a lot of unit, right? You have voltage, you have current, you have ohms, and then you may have other thing. So you have a lot of units. So it's a bit difficult for you to normalize or because standardize everything. So we can say normalization, it means we don't want unit. So we use the actual quantity divided by the base value of the quantity. So when ampere divided by ampere, it means what? Dimensionless means no unit. If no units, then means you can actually compare. So what is per unit? So if this is an example lah. So if you have 50 kg, 40 kg, 45 kg, 55 kg, 48 kg, 55, 2 kg. So if I said, of course, we will give you a reference. So if reference to the first boy 50 kg, then divided by 50 is 1, divided by 50 is 0.8, divided by 50 is 0.9. So this one also divided by 50, divided by 50, divided by 50. Okay. So this is per unit. So per unit calculation, there is this is not important. There is this one. There's 2 important formula. Okay. Yeah, these 2 are the 2 important formulas. Yeah, let me explain to you. Okay, for those already watch the recorded video, can you tell me what is how you know that whether you want to use the wait, why my pen cannot function? Why I can't just use kg before? Not the one to don't do. I want to know. Not because of don't and don't do. It's because of this. This is formula 1. This is formula 2. Another third important formula will be another one. This one. Z base equals to this v squared over s. Okay. Normally you just need to use these 3 formula only. Okay. So this one also ZPU new This one also ZPU new. Then why we use actual over base new, and this one we use ZPU O. Then the long formula VO over V new power 2 S new over SO. Okay. How do you know that whether you want to use this or this? You don't know. So it's basically like this. If you are in a class, reference do not change. Roughly like that. So if you are in a class, okay, I say this one, the class of reference 50 kg. Okay, that means now you have a guy come in. Okay, this guy I say now I'm a new guy. Okay, now I'm 60 kg. In kg. Okay, in kg. Okay, that means it's going to use formula number 1. Okay, but now if another guy come in, this guy actually is from another class. The other class maybe reference is 60 kg. Okay, and now this one guy come in. with the old reference 60 kg, he want to join the new class, and now he already in PU. He already say it is, for example, it's 0.8. It's 0.8, for example. Then he come in 0.8. Then he is going to use formula number 2. Can you understand now? Can you understand better now? Can that's good. So what does it mean? Means if it is a totally new person, for example, given in voltage in ohms, normally voltage ohms or current ampere, that means you need to use the actual value divided by the base value. If they say already refer to an old value, old place, old reference value, then now they can tell you that this is now only 0.8 pu. You cannot say 0.8 join in here also 0.8, cannot, right? So means you need to use this old pu value 0.8 divided by the old base divided by the new base power 2, old base, new base power 2, then divided by the s new base for the s here, then and divided by the old s base o here. Then you get the new pu for this guy. Yeah, something like this. One reference versus, okay I can say so. Okay, so yeah, important formula C. I'm so nice. Ding, 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 ding. I really help you to summarize all these 1, 2, 3 important formula. Then per unit procedure, you have to normally not to say pick a base. Normally I will set the base for you, base value. I will set it, and then base voltage. Then calculate the impedance, calculate the current, then convert the actual values to the this is procedure. So basically, you convert all to pu. Then you draw the impedance diagram. Then you solve the questions. Normally they ask you to find current. Then you convert back to the actual. So this is a per unit free zone. Okay, so you can look at this. All this value, all this value, consider O value. Give you 5 star. That's good. O value. So what is the new value? O value. What are the new reference value? New reference value is only here. Using base value of 30 kVA and 240 watts in zone 1. Inilah dia. This is the new base value. Can you understand? So diagram, given in diagram, old value. New value is only one line like this only. And definitely they will tell you mana dia start from where. So start from zone 1, it means zone 1 here. So first thing that you need to do is all the transformer, okay, voltage can only change values, right, after you go through the transformer. So only the voltage will step up or down at the or after the transformer. Okay, so means when they say they start 240 watt in zone 1, that means 240 watt will be here. Okay, so zone 2, you go to zone 2, right, means after transformer, right, transformer 1. So it will step up or down according to the transformer ratio, 240 and 480. So this one 240, this side also 480 lor. Understand? Then it jump to the after another transformer, zone 3 here. For this one 460 and 115. 460 divided by 115, I think it's 4 times, right? Yeah, 4 times. So 480 divided by 4 times is actually, so it's actually 120 here. Can you understand? So all these three, 240 watt, 480 watt, and 120 watt will be the new base voltage values at each area here. Okay, means if you are considered here, line, that means you need to use 480 as a new base value. If you are considering here, that means you need to use 120 watt for area here. Okay, and S is always the same, 30 kV, all the places same. So why? Because back to the formula, you have the V base O, S base O V base new and S base O. So the new one always the same, no need to change the value. But the new V base will be, yeah, they give you one, understand? They give you one value, but you cannot use all the 240 here, 240 here, 240 here. Understand? Yes, yes. You need to go up and down according to the transformer ratio, and only voltage need to do this only. So that's why normally first step will be use a new voltage and then check where is the transformer, and then step up or down according to the transformer ratio. I do this one first. 240, 480, 120. Okay, done. Then only you start to draw the per unit. So how many components are there? There are one component voltage here, T1 here, X line here, T2 here, load here. So 1, 2, 3, 4, 5, 5 components. So that means you need to do 5 components. So for example, yeah, basically only these two formula. Let me say this is formula 1. This is formula 2. So can you tell me, zone 1 here, yeah, you have VS220. You need to use formula 1 or 2? Yeah, Brian, so fast. Formula 1, right? Because this is actual voltage. So means you need, so how you need to do actual a bit? 220 base value. Base value just like we said, 240. Zone 1 here, 240. So it's 220. So then only we will write this VS PU will be equals to 220 divided by 240. So you get 0 point something lah. Okay, then next T1, then sorry, normally we write this X because we all refer to X reactance. Then will be X. This one okay lah. This one still okay. This one VSPU okay. VSPU okay. Then we X T1 PU. So we equals to. So this one we need to use T1. We need to use formula 1 or formula 2. Yes, Renjie. Okay, because they tell you O reference value they tell you is 0.1 PU or then definitely you need to use this one. So 0.1 PU base O. So it depends on you whether you want to use a primary side or secondary side. For transformer, you can choose primary or secondary side. So if you want to choose primary side, 240, O1 will be 240. A new one just out here, 240, right? 240 power 2. S new S value, new base value, 30K. So 30K, 30 here, divided by here. Yeah, the O1 also, O1, this is O1 also 30. That's why basically it's 0.1 as well lah. Means the O1 and the new one is the same. Then here, okay, can do Okay, I give you 5 minutes to go through this. Can you try to do line here? So this one should use what? Should use 1, right? Then this one should use formula 2. This one also should use formula 1 because in ohms, right? Okay, I give you 5 minutes. Try to do this. Oh yeah, today is a replacement ma. So until 6 lor. So tomorrow no class. Okay. Yeah, you feel tired already, you see. Okay, it's okay. I think I will end after this lah. Yeah, I then end already. Okay. So after I complete this example, then we will end the class. Okay, then you all can continue with the tutorial. Okay. I will discuss with you all the tutorial answer in coming Wednesday. Okay. Okay. Let's go through here. This is important. So I don't want to go through too fast. Yeah. So this chapter I will spend some time to discuss the tutorial view. Okay. So line here you know right. Then X line, X line, PU should be equals to actual 2 ohm divided by the base value. So what is the base value? This is the ohms, right? Can you say the base value is just not 480 watt? Cannot, right? This is voltage, this is ohms, right? So base value also need to in ohms. So how are you going to find the ohms? That's why I say three important formula. One formula, two formula, know already. This formula. So you change the V squared over S to get Z base. So that's why here the so here the Z base here will be V squared over S. So what is the V value? Anyone can tell me what's the V value here? In zone 2, you have to use 480. So it's 480 power 2 divided by the S value 30K. So once you get your Z base, then you put in here Z base. Then you get your X line PU value, okay? Then XT2 transformer 2 here 0.1 O value here. Then V base O will be C4XD 460. So if you use 460, then you use 460. New value will be 480 power 2. Give me 1 minute. Okay, delivery. Okay, where are we? So sorry, so the new S value will be 30 over the O value only 20K. Can see that 20K. So then you get a T2 new PU value. Can you get it? So why 460 and 480? 460 here, then 480 just now our new value here, right? 480. Okay. So if you want to use 115 secondary side, then will be 120. Give me another minute. Okay, I have another announcement. Just now the lab assistant just replied me. Okay, week 7 confirm already. So means our lab will change to 6 and 7. Okay. I will later post to Google Classroom. Time and same time, 8 to 2 p.m. I haven't later lah. I will make maybe a Google Excel form. Then you fill in which slot you prefer. Okay. Yeah, you post to Google Classroom. Okay. Then yeah, you need to choose your partner. How many of you already? 14 of you. 3 to 4 students in the group. Okay. 3 to 4 students in the group. Then you can choose the time that you want. Where are we? Okay, this one done. Okay, so why you know that it's 460 and 480, right? So some students always make a mistake. They use 460 divided by 115. Cannot. Get what I mean? You need to use primary side with primary side, secondary side with secondary side. Okay, cannot cross. Then I think last one will be load. So load here, same thing. Then you need to, this is in ohms. Then the new value, base value is in voltage. So that's why you need to use V squared over S. So now the V will be 120. Okay, 120 because this area is 120. Then power 2 divided by S, 30K. So the load here, PU also use a number 1, equation 1, then divided by the Z base. Then you get the load, impedance in PU. Okay, and one small thing that you need to take note is, can you see this is only real, and then this is with real and imaginary. If conclusion is like this, don't ask me why. The conclusion is like this. If you only have real, that means you come out, the answer will be in J. If you have real and imaginary, then means your answer out will be real plus J, imaginary. Can you understand what I mean? Magnitude only. Yes, always magnitude only. What do you mean by magnitude only? Understand? So if only 2 ohms, then come out the answer, you automatically need to put a J. Because why? Because actually they tell you the X line. X is reactance. So you need to put a J. But then my conclusion is I really go through quite many years and found out only real and imaginary, then only have real and imaginary. Other than that, all you need to put J. Okay. Then this is how they get the answer. Why they say they need to use V squared over S base. Then current, base current S over V, then you get current. This is not so important formula, but you may need to use it also sometimes. So you can knock down here this one. So the transformer 2, then line PU, so that the actual divided by base, then load actual divided by the base. So then you get this diagram. So you can see this is a VS supply voltage PU, then transformer 1 PU, line PU, transformer 2 PU, load PU. So this is what we call impedance diagram. Okay, impedance diagram. Yeah, so basically it's very easy, and you may have colors missing only. Okay, so zone 1, zone 2, zone 3. Okay, after the transformer change value. So that's why the question actually asked for, I think, the load voltage. I think load PU and the IS is basically just a series circuit, so you can use voltage divided by all the impedance add together. Then so they want the load PU, so you need to use I base 3 to multiply with the actual base value, then you get back the actual value. Just now you reference 50 kg, now you are 0.8, so you 0.8 times back with 50 kg, so you get back your kg. Okay, any questions? So this is what per unit. This is what about per unit. Any question, anything that you need me to explain one more time? My computer already, my laptop already start to hang. Any question? If you don't have any questions, then This sponsor, yeah, ask UC to sponsor. Your UC sponsor, but the sponsor netbook actually also not a good quality. Okay, yeah, then I won't discuss the tutorial, but just I briefly tell you only. Okay. Question 1, 2, 3. Tutorial 3 I can start to do 1, 2, 3 okay lah. 4 actually about transformer then per unit then this kind of questions So all these values actually is O value O value. Okay. Then OLD O value. Okay. So the new value will be here. Okay. A common base of this one all at the generator side. Okay. So means you start with generator side. Then you already hang generator side here. Okay. Then also question 8. All these will be O value. New value is only new base 100 kVA 2004. Okay. Any question? How do I read that kind of circuit diagram? You don't need to read the circuit diagram. What do you want to read? Why you need to read? So it means that component, then you need to check. Okay, it's basically this. So what you need to do is G. You need to find out XGO. Just now the new O new thing. Then XT1, XT2, then XT3, then XT4. 1, 2, 3, 4, right? You have 1, 2, 3, 4, right? Then line 1, line 2, X line 1, X line 2. Then I think you have X motor, X load. Like that only. Yes, you need to know component. Then the diagram is basically the same shape like this. Okay, then same to this. But of course, if you maybe I show you my answer about solution. This is tutorial 4, right? Solution 1 to 4. Sorry, tutorial 3. Ayo, very hang. Okay. The diagram is basically like this. Something like this. See? Okay. Then T1, T2, T1 line, T2, T3 line, T2. Okay. Then the motor, then the load. Same to this. Okay. The diagram actually just follow the shape of the circuit only. Nicholas, am I answering your question? How do we convert in the? Am I answering your questions? Yeah, you just need to find out all the values. Then the diagram is exactly like this. Just that you no need to draw out transformer. Just you can draw a box or you can draw a coin like that to represent the thing. You define the zone actually is not an important thing. The zone means all the transformer you can put a stroke like this. Understand? That means later on then you can so that's why here will be 1 voltage, then another voltage here, another voltage here, another voltage here, another voltage value here, another voltage value here. Can you get what I mean? T1 and T3 are parallel. That means that's why your diagram will be generator, then transformer 1, then line 1, then transformer 2, then like that then transformer 3, line 2, 5, 6, and then transformer 4. Then you have another motor load and then load. Like that. Can you understand what I want to tell you, Nicholas? Okay, the diagram actually is not a main thing. If you can't draw a diagram, you basically only lost 2 marks only. But this kind of thing is important. Okay, this kind of calculations actually very easy. Just a same formula, repeat only, and then every parts I give 2 marks, 2 marks, 2 marks, 2 marks. So that's why it end up it can be 10, 15 marks. Okay. 2 marks only ma. If you can't draw, it's usually that never mind, just leave it. That's why I say a lot of students can score for this paper because nothing much I can deduct marks actually. Okay. So if you are okay, then we will end our class here. So basically, I would like you to complete this tutorial 3, and then continue with the recorded video lecture 4. Okay. Then Friday, I will discuss with you this tutorial, then and go through with you the lecture 4 main thing. Lecture 4 is really nothing, very short one. Okay. Yeah, don't worry lah, the 2 marks. Okay. Seriously, of course, if you already score badly, then I will close one eye, give a little bit of mark. Okay. As I say, if I can pass you, of course I will pass you. Okay. Normally, I want to pass you, but then the thing is your paper is really too worse and I give mark also can't help. That means that means it's definitely get a fail. Okay. So no worry. Okay, so if you don't have any question, then we will end our class here. Okay, see you. Bye. Enjoy your CNY celebration then. Okay, yeah, you can write me with 5 stars. Thanks. Bye.